Dzień dobry I witam to my session. I learned a new word this year. You all know it, and that's a problem for me for my session. Smacznego. It's okay, it's bon appetit, yeah? The challenge I have today, or now in my 60-minute session, is to keep you awake. Otherwise you will fall in a soup coma, but I promise that I will show you much demos. It's more like cinema. You can relax, but don't sleep. Yeah? If you snore, then please not too loud, but I can accept it. Okay, let's go. Time is short. This, first of all, a big thank you to all the sponsors of this event. Everybody of you know that without sponsors, these events couldn't happen to that price, what you paid for it. And the speakers are doing that for free. Thank you to all the speakers here in the audience. And so thank you for you at the audience coming to my session, nearby full. A big thank you to Australia, right? Nay, you're from Australia. Yeah, she's the wife from a good fellow from Austria. So, from Australia, sorry. Okay, okay, this is me. A few of you know me. Most important thing is only my email address. The rest is commercial. Forget about this. My email address, that's the really important thing on this slide here. If you have any questions concerning the engine, special CDC, please drop me an email. I promise to answer really every single question. A few questions I'm not willing to answer. This is, what is my credit card number? What is the CVC of the credit card number? And what does my wife like best when we go out for dinner? But everything concerning SQL Server, do not hesitate to drop me an email. This it is. This is our agenda. It's quite short, you see. But CDC has so many features we cannot completely fill into 60 minutes. But I want to give you an overview what CDC can do for you and how you can manage CDC. There are a few pitfalls what you have to consider when you're dealing with CDC, and one of them I want to show you too in a demo. First question of all of you, to all of you, who of you is working with BI stuff? Yeah. Your fault. Anybody is working with CDC? Okay, that's great. A few of you. So for the rest of you, it's brand new stuff, right? Yeah. That's cool. It has a little bit to do with the engine, but a lot of things to do normally with BI, because change data capture is the thing what primarily is using for BI to get data into data warehouse. But I want to show you the technique. Anybody is using temporal tables in 2016? Nobody. Oh. Anybody who has been yesterday in the temporal table session? Okay, good. What I will do is, in a few, when I'm explaining my demos or explaining the slides, I will try to compare temporal tables to CDC, because in a few situations it might be much better to have temporal tables instead of CDC. Okay, this is the agenda. CDC, what is change data capture? What I want to do is I want to give you an overview of the change data capture feature, how we can implement it. We have lots of demos for that. The configuration of change data capture and how we can use change data capture. Last but not least, I will give you a checklist to cover performance and security. And normally what I would like to do is I have a demo fresh from the field. I have a customer where I've implemented CDC for audit reasons. I have decided not to take this as a demo, but there's currently, while I'm talking here, the demo in the background running. So, oh yeah, most important for everybody who wants to use CDC. This is not a performance session. What does this mean? CDC is working with functions. But the bad thing with the functions, what you're using with CDC, they are not inline functions, they are multi-line functions. So if you're using them, if you want to join them with normal tables, forget about performance. Okay? So here we are. CDC has been supported by these editions. Oh, I made a mistake. Sorry. Unfortunately, if you are working with SQL 2014 or earlier, you have a huge problem with CDC. You can't use this. Yeah? Here. Okay. So, if you're working with 2014 or earlier, it's a feature of Enterprise Edition. That means if you want to use CDC, you have to get to your wallet, put a few thousands out of the wallet, and have to pay for it. But the good thing, here is the good thing. If you're working with 2016, but especially watch to this, SP1, then this feature is open for you in every single edition. Why is it not available in Express Edition? There is one simple reason for that. CDC requires the SQL Server agent, and the SQL Server agent is not part of Express Edition. That's the reason why you can't use it. Okay? So, what is CDC doing in general? Well, CDC traces, that's the huge difference to temporal tables, insert statements. So that means when you insert new data into your table, they will be tracked. Update and delete activity of your SQL Server table. So every single DML operation, what you're doing, will be recorded and will be transferred into a history table, where then the BI guys can come with their SSIS packages and grab them and put them into the data warehouse, for example. The good thing with change data capture is that the changes are available in a relational format, and that makes it so wonderful from my point of view before temporal tables were coming into the game. Because anybody knows change tracking? Anybody heard about change tracking? Oh yeah, good, yeah. You know, the problem with change tracking is that you don't have a full record, you only have a version number, and you have to make sure that you get the right data. So in CDC, it is a really normal table what you can access. You can get info from this history table. The column information is captured from the modified rows and it's stored in these change tables. Here comes the good thing. Oh, here comes the good thing. Two things. Welcome. Vita. So here comes the good thing. If anybody is working or is planning to work with temporal tables, then, and you don't want to collect really every single column of what where it's a change in, then CDC is definitely better for you, because in CDC you can define the columns which should be tracked. With temporal tables, no chance, all or nothing. So it's especially when you think about the mass of data what you are capturing. And now comes the bad point. Table valued functions are provided to allow systematic access to the change data by the consumers. It's, from my point of view, yeah, you can use it, but you can make it a little bit better if you use the system tables itself. Here is it, how it works, and that makes it so interesting against temporal tables. The source of all changes is the SQL Server transaction log, and here we see why Microsoft has decided to put it as an enterprise feature. The one and only reason for that is simple: performance. Performance and concurrency. What does this mean? If you change data and you want to put the data into a history table, how would you do that if you don't know CDC or any other feature?
Trigger.
Triggers, perfect. Triggers or stored procedures. And if you use a trigger, then what will happen inside, what is happening inside the trigger is part of your user transaction. So that means if you transfer data into a history table, you make an insert, the trigger fires, and it puts data into the history table. What you then have is you have two resources open in one single transaction, and that may lead to deadlocks. Here is the demo. I promised you, demo, demo, demo. So, where's my mouse? Oh yeah. Old style temporal. Old style, yeah. You see, it's old style. It's from October 2015. So here I go to my master database, and what I'm doing now is I'm creating a database called DemoDB. Very simple. I create this table. Here we are. Go into it. And here's my scenario. What I do, I create a table called customer data. Very, very simple. I have a cluster key on the ID. And now comes the point that I want to collect the historical data. So in the moment I change something, it needs to be inserted into my history table. Here is how I implement this. The first thing what I'm doing, I'm an absolute fan of that. Use schemas to divide or separate history from normal tables. I can really recommend that. So I create a schema called history, and here is my history table. The history table has exactly the same time format, the same format, only the cluster key is changed because it's much bigger. I need to have the ID because it could be inserted multiple times. And I have a timestamp and the so-called action ID. The action ID is a very simple thing. That is because CDC is using a so-called action ID to identify what did happen. Yeah? I will show it in a few minutes. Come on, here we are. Now comes the heavy part, the hard part. I create now my trigger for an insert. That is really simple. What I'm doing is I define, let's say, an insert, let's say it's the ID 2. Okay, what I'm doing is take everything from the inserted table, put it into the history table. Very simple, short story. Here we are. Now I create the update trigger, a little bit more complicated, because what I have to do in the update, and that's because I want to replace CDC with old style, is when I run an update on a row, SQL Server needs to store the former values and the new values. So you have one row for the before update and one for the after update. So every single time one update causes 2 rows. Ooh. Here we are. And we have the delete event. Same procedure. The only thing what I'm doing is I'm inserting into my history table everything which is in the deleted table, trigger table. Here we go. So, what I'm doing, but only for simplifying the access to the data, is that I create a wrapper function which is very simple. I say, please select from my history data based on the ID, start, end date, what changes do I have? So, that's only a helper. Here we go. I insert 2 new customers. Here we are. One has the ID 1, that's customer A. Customer B has the ID 2. Quite simple. With the insert statement, the data has been automatically with the trigger transferred to the history table, and that can be quite easily checked. Let's say what has changed for the customer with the ID 1 between 21st of September 2016 and now. And here you see, and what you can see here is I marked it as an insert statement. So the record is new. Pretty cool. And it's very easy. Now I run an update. Oh, it's Microsoft. Interesting. Go. Here we are. And now I take the same record and update the street. And what I now have is not so funny. I now have 5 records. Every single update causes 2 additional rows in the table. Oops. Yeah? Here we are. And now I delete the table. The record. And now I have the full history of the customer with the ID 1. Here I see that I made an insert, then I updated it, this is the new value, then I updated it again, here is the new value, and then I deleted it. Maybe they went bankrupt or anything like this. Here comes the problem. When you have triggers, or when you implement triggers, you're in a high danger of deadlock scenarios. Here is how it can work for you. Let's say you are running your system, you are updating, you're running inserts, deletes, and so on. And in the meantime, a different process is trying to get the data, putting them into the data warehouse by calling our function. Here we go. What I'm doing, that is the only reason why I take this isolation level is that it holds the locks on the resources while I'm in a user-defined transaction. That's the only reason for that. Yeah? It's not to say, okay, that is only when you have transaction isolation level serializable. No, 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 no. Here I start my transaction. And now look what happens. Excuse me. Look for any changes what I have in my customer data. Here is one, that the insert statement. And now think that this statement will be called by a transaction hook which will get the data and put them into the data warehouse. Let's see what resources have been or will be blocked if you run a select statement on these objects. That can be made visible here, and that's the reason why I use serializable. What you can see here that's quite interesting is this. Forget about range logs, whatever it is. Concentrate on that. You see that I have a intent shared log on my customer data table and on this function which called the history customer data. So now I have two resources, two tables or two resources in two different tables locked. And now comes the funny thing. While we are collecting data to put them into the data warehouse with this function, another process comes in and is doing this. I start my transaction and I want to update my customer data with the ID 2. Will that work for me? Will that work? No, because the logs are not compatible to each other, so this process has now to wait until the logs get released from the first process. In the meantime, we get to this again, and here comes the problem. I run again now a select statement on the DBO customer data and see what happens. Wait a second. Yeah, here we are. Deadlock. And that is, I promise, whenever you have your self-defined solutions for history, that might occur. If two processes are trying to get to the same resources, trying to fight for the same resources, and they're in a deadlock situation, so one will not give place for the other, then you run into the deadlock. That is the danger of the solution, what you will use. So I roll it back. Come on. Here we are. Easy? Hopefully, yes. Are you awake? Yes. No? Come on. Then we go to the next part. So what CDC is doing, that is brilliant from my point of view. With CDC, you are separating the portion of inserting, updating, and deleting your original table, and it's completely separated from the transfer to the history table. That is because we have now here a so-called log reader in it. So the DML operations are added to the transaction log, quite easy. That's a normal behavior of every single database, and they will stay in the transaction log as long as the log reader, the transaction log serves as the input for the CDC, and now the CDC process reads on the transaction log and adds information about the changes to the tracked table, associated change table. What does this mean for you? If you have seen my previous demo where we ran into the deadlock, we saw that we have concurrency on both tables. Here, this could never ever happen because your transaction is isolated and based only on the original table. Then it will be transferred to the transaction log, and there it stays. Process done. That's the normal behavior. Put it into the transaction log, finished. And now the CDC process is in the background working for that, and it's trying to read from the log all the changes which have been made to the CDC tracked tables. They will be getting out of the transaction log and will be filled into the history table. That's a very fantastic thing. That makes CDC, from my point of view, a very, very valuable functionality if you have systems which depend on very, very high transactional rates. Temporal tables cannot work with that. Temporal tables do not use a log reader in the background, but if you're using temporal tables, the insert in the history table is the same as here, part of the user transaction. That makes CDC much, much better than temporal tables. So now we come to the point where we want to use the data. So when we have the data in the log, the capture process will grab them and put them into the history tables, and what we can do then is we can use functions to get the data and put them, just for example, into a data warehouse. This is only one possible solution where I can use CDC. I used it with a big customer in Frankfurt for audits. What they did was very simple. They had a, let's say, a hot database, really hot. There was a strong secret personal data in, and they wanted to make sure that every single change on text data, on personal data, need to be tracked, that they know who did it. And therefore we use CDC for security reasons for them as a solution. The filtered result that is used by an application process, SSIS. SSIS has components for CDC. So anybody of you is doing the BI stuff and using with SSIS, I think that you definitely know that you have the controls for CDC. How can you implement change data capture? Now comes the bad point for people. Please, I don't want to offend someone. That's really important. Now comes the bad point for people who don't like to work with keyboard and with commands. There is no GUI for CDC. There is no wizard for CDC. There's nobody who is saying, may I help you with your CDC? No. If you want to have help with CDC, you can hire me or Erland or anybody else, and you put some little money in the pocket and then we come and help you. The point is that if you want to work with CDC, you have to use stored procedures. Great thing. Okay, the BI people are not laughing anymore, but the others may think, oh yeah, that's great stuff, because it's quite fast. So, yeah, come in. Ah, you're doing the photos. Okay. No. So, what do you need to do? First of all, a database needs to be prepared to use change data capture. It's quite simple. You have a stored procedure called SP, System Stored Procedure, CDC, enable DB. That is the really first thing what you need to do. Before it's not enabled, you can't use the functionality of CDC. It does not automatically mean that now from this point on every single table is part of CDC and every single change will be tracked. No, not working. Let's see how it works. Take my mouse. Enabling CDC. Here we go. I think I missed one thing that is really important. Otherwise, another demo will enabling. Come on. Oh, deadlock. Here it is. Roll back. And here. In the kitchen. Okay. So, how to implement CDC? The first thing what you need to do is you have to enable CDC for your database. I have a database DemoDB, and here comes the first point. What I think what is really important if you're planning CDC for a database. The problem here is that the people think, okay, that's very easy. We have one large database, put everything into one file. You can do this. But I would strongly recommend not to do this. What did we do with our customer? By the way, the customer is working with SQL 2014. SQL 2014, you know, CDC can only be used with Enterprise Edition. And if you're working with Enterprise Edition, you have a good feature for backups. You can do the piecemeal restore, file group restore. And that is a really good thing. Let's say you have lots of data into your file group from your history data, then you can restore your primary file group, disable CDC, otherwise it will not work, and then they can work, and in the meantime you can restore your file group with the history data. That's a cool thing. So what I strongly recommend is what you should do, separate your history data from your process data by using a dedicated file group and a dedicated file. Here comes the thing. What I'm doing is I'm creating a new file group called CDC. Here we are. And then, what I'm doing then is, I implement a new database file in that file group. By the way, that can be done by mouse and GUI too. Okay? So, I don't want to disappoint all of you here. So, here we are. The next thing that comes into the game, for me a very, very important thing if you're working with high security data, protect your data. What I'm doing is I create a role called CDC admin. There I put the data, the people in who are allowed to access the history data. You will see in a few minutes when I show how you implement CDC for a table. Therefore, you need it. Here I go. And now comes the good point. Here. Instead of open a dialog, looking for options, click here, click there, only this one line. SP CDC enable DB. The point here is that SP enable CDC enable DB, CDC enable DB is it doesn't allow any parameters, which means that you have to be in the database which you want to allow CDC functionality. Here we go. Done. Finished. Show me one GUI where can you do it much faster than this way. Huh? Okay. Now we can check the status, and that is something you should always check. There is an attribute called is CDC enabled. If it's true, then you know CDC is for that database enabled. You can check it with this databases. What has been done now? Let's check, because SP and SP SYS enable SYS CDC enable DB is not only setting a flag in the SYS databases. No, it's doing much more. And here we go. What the system was doing is it was creating a new SQL user called CDC. This is for the internal access of the CDC process to the data and to the metadata. It is a SQL user, but there is no corresponding login to that. That's only a database user without corresponding login. It's for internal use of CDC. If someone is asking what will happen if I have such a user, I didn't test it. Yeah? But I can do it after the session. So, what has been done furthermore? Here we have the point. The process has created a new schema called CDC. This schema will be used for the storage of all system-relevant functions which SQL Server is using to maintain CDC operations. You can't avoid this. And here are the objects. Look to this. I have to zoom in. That looks so funny. And that is sometimes a little bit annoying when I see how the quality management sometimes at Microsoft works. You see, we have a few functions twice, right? The point is, you will have it once with a separate space in between and once not. That's cool, huh? Yeah, that is, yeah. We can select, it seems to be. No. Point here is that these functions here are templates. When you implement when you enable CDC on a table, SQL Server grab these functions and make a copy of them dedicated for the table which will use CDC. You will see it. Then we have tables, index columns, user tables. This is, from my point of view, one of the most interesting table, the LSN time mapping, because I'm not familiar with LSNs, I'm more familiar with time. Then I say, hey, when did this change happen? And it gives me the LSN. To be honest, I don't know when it did happen. The good thing is, here is a translation. The LSN, and the corresponding daytime when it has happened. And if you store procedures, that's it, by the way. DDL history, I will show it to you, that you can see when you make changes, metadata changes, that you can see the information, what changes have been done. Think of your data warehouse. Someone is changing a table, and you want to insert the data. Let's say I drop a column. How do you know that? Check the change table, then you see what changes have been done, and you can maybe adapt them on your data warehouse. Lots of information, lots of useful information, lots of it depends information. Yeah? So when you have enabled CDC, the main part is done. So CDC needs this function And if you would like to have more details about it, then you can use this link. What will happen when CDC enabled DB is running? The first thing is that a database user called CDC will be created. It has no lock in it because it's for internal use from CDC itself. The next thing is that a new database schema CDC will be created. And here you see the topic. The former created user is the owner of the schema. In this schema, all the necessary objects which are required for CDC will be implemented as templates and helper functions or store procedures. So now, when CDC is enabled, what is the next step? The next step is that you grab the poor little tiny table and say, I lock you. And that you can do with SPCDC enabled table. Easy. No GUI, only store procedures. With this function, or with the stored procedure, there you can create a copy, or not really a copy, but you create the history table for the tracking of the data. Let's see how it works. Before I go to it, look to this. This stored procedure is not so easy as the enable DB stored procedure. The reason is very simple. It needs a few more parameters, but only a few. Source schema, it's quite easy, isn't it? In what schema is the table I want to track? What is the source name? What is the table which I want to track? The role name, a really cool thing. Because think of security. Who is allowed to have access to the history data? If you have an audit issue on those systems, it might be that you, especially when you have high secure data, that you would run into trouble. So role name, only dedicated users are allowed to access the history data. The capture instance, that sounds a little bit difficult. The capture instance is nothing else but only a logical name. You can name it, so let's say we will monitor the employees table in a few seconds, and I can give it a fantasy name. You know, Rotkäppchen? You can name it whatever you want. The most essential thing here is that you need to keep this name in mind when you access the data by functions, because you have to give this logical name when you run run a select statement. Supports net changes. Supports net changes. This means maybe you have seen in my current, in my previous demo, that when I run an update on one attribute and then on another one, I created 4 records. Let's say you're in one transaction and you first update the street, then the name. Then it will be normally 2 different transactional parts. So it will generate 4 rows. With the net changes, it summarizes it, and then it shows the net, so as it says, the total changes in 1 row. That's much easier for you to transfer them to the data warehouse. If you say it supports net changes, then you need to name or give the name of the index, because it requires a primary key or a unique index, and then you have to name which index identify the uniqueness of your record. Capture column list, a great thing, really a great thing. Because if you're using temporal tables, you don't have a choice. You have to use every single column in it. That's ANSI standard. But if you're using CDC, change data capture, it does mean that you say, oh, I don't want to have all these columns in my capturing process. I only want to see when someone is, let's say, changing my salaries. Or someone is changing the last name, because she's married, he's married, what else? So you can define by the capture column list, the comma-separated list, the columns which should be tracked. That is, from my point of view, one of the great benefits you have from CDC instead of temporal tables. File group name, you have seen it. There you can say on which file group should the CDC table, the track table, the history data, be stored. Allow partition switch. Anybody here is working with partitioning? You know partition switch, what it does mean? That you put out a complete partition and switch and put in a new one. That's called partition switch. The big point here is if you have partition switch, it's a metadata change. It has nothing to do with delete row, delete row, delete row, delete row. What does this mean if you have a metadata switch, a metadata change? It will not track the single rows which have been changed with the metadata at all. So, and if you allow this, then absolutely clear, you will lose data in your history. So let's say you have one partition for 2005, and you have run CDC, you're running CDC on that table, and you say, I want to get rid of 2005 and put them into another partition. And you switch that, you switch it out and put in new partition, then it will not be recorded in your history table. So therefore, you should be really careful if you want to use this. Yeah? It will not be tracked. Let's see how it works. That's a funny thing. Because there will a lot of things happen in that moment. Here we are. Oh, February 2015. Ooh. I go into my DemoDB. Here is my customer data. So if I want to use CDC enable table, go step by step. I want to track from dbo.customerdata, and only members of the group CDC admin are allowed to access the data. The logical name when I access the data is customer data. It supports net changes, and the uniqueness of my record can be found in the primary key customer data index, PK customer index. I want to capture really every column. That's why I have the null in. And please store the history data in the file group named CDC, and I allow, but it's nonsense, there is no partitions in, I allow partition switches. See how long it will take. In the meantime, oh, live. Oh, let's check this. Gosh, what's going on? I tested it. Let's have a look. Oh. Not good. Not good. Why? Customer data. Let's check it. The rest is working without that, but it's only for enabling table situation. Just a secondo. I know. I dropped it. It's live, so TV is watching us. No problem. So here we go. Here it is. Put it in. Done. So now it should work. Hopefully. Too much windows open and enable. So here we are. So now once again, try to enable it and see how long it takes. In the meantime, I can serve water, I can dance, I can sing. It takes a time. And here, oh, now it's finished. Yay! It took only 6 seconds. Seems to be a little bit long. I promise, I don't have an example for it, but I promise. In the moment I would enable a second table for CDC, it will be in less than a second. The reason is very simple, but let me explain. This comes later on. The point here is that when SQL Server creates, when SQL Server creates a CDC, activates CDC on an object, what SQL Server will do is this here. Forget about the first 2 jobs here. CDC will create 2 jobs. The first one is DemoDB capture, so getting the data out of the transaction log, and the second one is the cleanup. The point here is, think back of how CDC is working. You're running your insert, update, and delete. And what SQL Server then will do, it has to watch, has to look in the transaction log and grab the data. It has to capture the data. So SQL Server will use this job here to get the data out of the log and putting them in the history table. Here comes the good thing for the second second job. If you think about working with temporal tables, and a few of you were yesterday in the temporal table session, I remember. If you are working with temporal tables, you do not have a chance, if you're working on-prem, to delete old records. That means you have to disable system versioning, drop off the columns, the rows you don't want to have, and then have to enable it again. CDC is completely different. What CDC is doing, CDC is cleaning up everything what is older than default 3 days. So you only get the data for 3 days and then you can get rid of it. But the process will take care of it and delete the records. That's the easiest thing. And here you see the huge difference. While temporal tables is really for auditing and for storing history data, CDC is more oriented to the BI stack. You get the data, want to grab them and want to put them in the data warehouse, and then you don't need it anymore. So,
just to ask, the controls in the SSIS, they are just a GUI for such implementation, yeah?
Really, yeah? In SSIS?
Yeah, I was asking.
Oh, I don't have it. No. Oh, BI. BI is if you would say. Oh, what is a good analogy? So BI is for me completely different. I know that it's there, but don't ask me for that. I don't have a clue about that. So that is the point where CDC comes into the game with implementation. From my point of view, the really good thing here is, due to the fact that you can use stored procedures, you can completely create your script and run it then on any machine to roll it on the machines, roll it out. Now comes the heavy part, to query the system. As I promised, this is definitely not a performance session here, but I need to show you how you can work with CDC, how you can query the data. I don't know how it's working in SSIS, but here comes it if you're doing it with native T-SQL. What did I do? In the background, there is a process running. Here is it. Here is my process. And what it did, since we are talking and having fun together, it was changing permanently records in the background. Every 5 seconds there was one change. So we have enough demo data to check how the system is working. Here comes the demo. We don't need this space. You know the name of my server. Yes. Here I go into my customers' orders. And what I did, just for information, I have enabled CDC for my table called employees. I named the alias as employees2. What SQL Server then is automatically doing is, it's creating the history table named by the alias _CT, change tracking. Let's look what's in. That looks strange, right? Here you see the data. Here you see very, very funny stuff. You see a start LSN, an end LSN, sequence value, operation looks great. The update mask seems promising. Everybody knows what this means. And here you see the data. That means we have 5 columns before our original data, which are used by CDC, and these are the additional columns in CDC. And this is a drawback if you decide, if you are a decision want to do temporal tables or CDC. CDC is using these columns and you cannot avoid them. They are always in the history table, always. What do they mean? The good thing is you see 5 columns, but you only need 4. Because this is, you see 5 and 4. The SQL Server 2012, the end LSN is never ever recorded again. So if you're dealing with that feature and you have 2012 or later, this is not being used. Start LSN, here comes the point. I said at the beginning that CDC is participating from the transaction log. What is the transaction log storing beside the way what it should do? An LSN, a log shipping number. So everything what you're doing with CDC is based on this transaction log. Therefore, SQL Server is not storing a timestamp when the change did happen, but the log shipping number. Log sequence number. Sorry, log sequence number. Sorry. Freudscher. That was Freud. So log sequence number, it stores it and not the time. But based on the log sequence number, I know when it did happen. Yeah? So the second column will not be used. Selection value, or that does mean if you have multiple statements in one transaction, then you have different start LSNs, but they're all completely in one big transaction. And there you can identify what changes have been done in one single transaction. That's a good point. The operation, yeah, fantastic. We have we have 4 different operations. Delete is simple, insert is simple. The update could be the problem. In update we have 2 different operations, and they will always be logged every single time 2 records. What was the previous value or previous record? What was the new record? That will be tracked. And the update mask, this is a little bit complicated, but don't worry, I have a demo for it, how you can calculate what column has been changed. There is in the script in, okay? So these are the columns you have in every single CDC table, which costs you additional space. Yeah? Think of that when you think about CDC. So we see our data, but to be honest, so 700 records in. With this kind of data, we can do nothing. Absolutely nothing. So how can we run a query against it? The big problem here is, if you're running SSIS packages, you don't want to have the log sequence number, but you want to have the timestamp. And here it comes. What you have, I set it to you, everything is fulfilled with functions. Here's the first one. What you do is, here I get the last start LSN, so the max LSN, and what you can do is, you can use the function fn cdc map lsn to time. Oh, that's like grep, yeah? And that will give you out the corresponding timestamp. When did it happen? Let's check it out. Here we are. That was only a few seconds before. What? Oh, yeah. Oh, good. Oh. So, yesterday there was a session about temporal tables. A huge, big difference is temporal tables are storing UTC timestamps. When you're working with CDC, it's the local time what is stored. So if you have data warehouses in different time zones, make sure that you query them or that you have to reconfigure it, let's say, to UTC. Yeah? Otherwise, you may run into trouble. Otherwise, then you should better use temporal tables for filling the data warehouse. It's local time. So this LSN to time here, and I use it, but as I said, not a performance session. Don't use a function in the output, but I have to. If you want to see when the changes has taken place, just for example here for the employee number 51, I run it with a function, and here we have the different times. And now I can work with that. The problem is, if you use it in a where clause, it's not non-searchable. Yeah? It always uses care. So here, now we come to a point where we need to calculate. We want to have a dedicated time window and want to have all the changes from within that time window. For example, you have an SSIS package which runs every 5 minutes to get the latest data from the table to put them into the data warehouse. So what you then need to do, in my case here at 60 minutes, what I need to do, and again, not performance. I have variables. I store my now minus 60 minutes and the actual. So now I know I want to have the last changes from it in 1 hour. My start and my end time. So here we go. Now I can map the time to LSN, vice versa. And here we go to the beginning, to the last LSN, and to the first LSN, which is in between this time frame. Here we are. So they see that it's vice versa. Instead of calculating from the LSN the dedicated time, you can go backward and say, from the time, give me the corresponding LSN, which is part of this, in this time frame. And now, what I can do is, based on this LSN, here we are. Looks funny, right? That is easy development based on functions. So what I'm doing is very simple. I go and ask for the LSN. The LSN must be greater or equal, and the LSN must be lower or equal than the end time. Here are my changes. Oops. Yeah. So I now have 760 rows which need to be transferred to the data warehouse. For me, this is, to be honest, this is from my point of view a little drawback. I wish that could be much easier than not with these functions. But I don't know how the SSIS modules, which are dedicated for CDC, are working. So maybe it is more based on that instead of querying it directly in T-SQL. But I don't know. Here we are. So now, a very, very interesting thing. I talked about the update mask. The update mask is an essential thing, really an essential thing. If you want to know which, and when you see one row, you see, let's say, 20 columns. How do you exactly know where was the change? What attribute has been changed? You need to compare. And therefore, you have the so-called update mask. The update mask is a binary value which you can convert to decimal. Let's check it here. By the way, I didn't mention it. You see, whenever I want to access my history data, I name it by the alias I was given it. Yeah? So the capture name. Here we are. And now look to this. Here is my update mask. This is simple. 255. I will explain it in detail. But here it's quite simple. If I see this value, it does mean that every single column has been updated. Or other words, this is a new record. Yeah? So that means every single value has been changed. And this update mask is essential for you to identify immediately what columns or what update do I need to run, because only this attribute has been changed, for example. But I want to show it to you. Here are the all changes. This is the function, what you need to know. And this is, again, from my point of view, really annoying. Let's say you have 20, 30, 40 tables which you want to use for change data capture. For every single table, you get exactly these functions. This one is named with FNCDC, get all changes, employee. If you have it for orders, then you have to use it with orders, order details. This is crazy. This is really, really crazy. Yeah? But yeah, it's working that way, unfortunately. So here I get all the changes in the employees table that were 460, but only the update results. Yeah? The update result mean that we get the data after the update, and what you can see here, the inserts and the deletes. Yeah? There is no before update. If you want to have all update old, now see what happened. We had 436 rows, now we have nearby the double of it. And here you can see it. Look to this. The 3 is the before update, the 4 is the after update. What you normally would do now is, oh, what is the update mask? 8, all right, I know it, 1, 2, 3. Here it is. Look what has changed. This is the attribute which has been changed. It has been changed from this value to this value. Try to spam him. I don't know his funny address, to be honest. Not a valid one. You can't spam him. So let's get a little bit closer to the update mask, because it's useful to know how you can calculate the changes, that you can quicker run your updates on the data warehouse. Yeah? Not only take the whole record and put it in. What I see very often is delete the old, put in the new. Oh no, you don't want to do this. Cost too much transaction. And if you're in an always-on availability cluster, everybody's happy about that. Here is the calculation. So what you can see is, so this hex value, the update mask, it depends on how many columns you have. Think about it as follows. What you have, this is my hex value, and for every single column, it will be the decimal. 1, 2, 4, 8, binary, so, binary, yes. 1, 2, 4, and so on. If this bit is set on, we know that this column has been updated. And now we go step by step, slowly to the demo, to recalculate or to calculate this part. What I want to do here first is, because you see it gets longer and longer here, the query, check this out. Here is my operation. I will not have the 2, 3, 4 or anything like this. I want to name it, say, okay, it's insert, pre-update, post-update. Here's my update mask, and what I'm first doing is I'm changing the binary value, so the hex value, sorry, to a decimal value. Then you can see the decimal value of the changes. Then I see my ID, first name, blah, blah, blah. And here comes the good thing. If you're not fit in math, I'm not, you can use functions. CDC functions. That's where they are developed for. The problem here is only, let's see what it happens. I here get the so-called ordinal column ID. That means in which position is this column in my history table, because that is mandatory. So go for it. Here we are, and now check this out. We take the first record. I see here the post update. So the update mask is A. That does mean that we have the bit 1, 2, 4, the fourth bit set to 1. Number 8. 1, 2, 4, 8. Yes. So now let's check this out. I'm in the fourth column. And now I go 1, 2, 3, 4. Here's my fourth column. And here you see the result when I use the function. Here you see what is the column offset. 2, 3, 4. You see that the column 4 is the email address. So I know it's not easy, honestly. But that makes sense to decrypt this value to know which columns have been changed. So, the question?
Yeah, I'm just wondering, have you checked, is this the same mask that the function columns updated in triggers returns?
What?
So in triggers, there is a function called, what they call them, update.
Ah, this update now. Ah, I know what you mean. So Ellen asked, what you can do is, in triggers, you can ask for the columns which has been updated in a trigger. I don't, if this is the same value, I'd never tested it. But a good idea, I will try to. Yeah?
So
We'll have like,
the
do we
next
meet in
session
Kiev
will
next week? That weekend? Are you in Kiev?
Yeah.
Then I have an explanation. Okay? Yes.
Because I think that this mask will reflect only those columns that are included from this CDC setup. But in the trigger, the
Yes.
mask will cover all columns in the
Right. Absolutely. Yes, you are right. Thank you. That's a good point. So he's absolutely right. I think too that this value will cover only the attributes which are in the CDC table, and therefore then I think it will not be the same.
You have something to test on this.
I do. yeah. You see, I see my families not so often, and you will grant me this value time. Okay. Good. Yes, sure.
How many columns can you track?
Oh, that is a cool thing. How many columns can we do at maximum?
Because yesterday Greco was describing a story who was communicating with the SharePoint team.
Oh, SharePoint! I know what you mean, yeah. SharePoint. No, I know what you mean.
They have in production something like 30,000 columns in one table.
30,000?
Yeah. Sparse columns. Sparse columns.
Yeah, that's sparse columns, yeah. But normal maximum is 1024.
For unsparse columns.
Yeah.
Okay, that was part of the story.
Uh,
Then the SharePoint team came and it was...
Yeah, but sparse columns is a little bit different. Oh, I think one more, please, and then we are open for questions. Yeah. So here you see, because I want to show you one thing which is really, really important. If you use CDC, then absolutely make sure. I have seen it in live. This is from the field. This is not an idea coming from me. The problem is that the team, the DBA team, did not monitor their jobs. Cool thing. See what happened. My database is, so first of all I need to disable CDC for the, just a second. Enable table, blah, 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 here we are. Yeah, here. So I disable, no, my master cannot be used, for God's sake. Okay, here we are. So here we are. Look what happens. Here are my jobs. You see that I have the capture job, and you see that I have the cleanup job. Forget about the cleanup job, that's only fun. The good thing is the capture job. Now what I'm doing is, my database is running in simple recovery mode, by the way. You can use CDC not only with full, but you can use it with simple recovery mode. Here comes the point. What the team did, they did not monitor their jobs, and what they did not recognize that the capture job did not work for 2 or 3 days. 2 or 3 days. Can you imagine what happened with the log?
Explosion.
It was exploding, yes. And here we go. So first of all, I want to, because I'm not lying, here is my recovery model. It's simple. The estimate is, I run my transaction, a checkpoint runs, my log is free. Perfect. Go for it. Here, let's check it. And here we are. Oh, a little bit is in, but that's peanuts. Here, it's empty. Yeah? So now, I stop the job. The customer orders captured. Go for it. So in the background, my execution, my update process is permanently running. Let's make sure that it's not running. Well, it's running, but now I stop it. Go. Okay, great. So now see what happens with the transaction log. I run it a few times. I now have currently 42 rows in it. It's not worth to see how much kilobytes or bytes it is. Only information is 42 rows. Oh, 48 rows. The reason is very simple. So every 5 seconds I need to be calm. Come on, come on. Hey, hurry up. Yeah. So the key point here is that now the lock, the acquired lock will not be released before the capture process has got the locked data and put them into the history table. So that means also my database is running in a simple recovery mode. My lock is growing. You have no chance, and it doesn't make sense that if you in an unknown hectic write this. No, it doesn't work because we're in a simple recovery mode. The reason why it's not working is that why it's not releasing the space is because the capture process is not running. Let's try it. So you see now it should be a few more. Yeah, 63. Now I activate it again. Refresh. Oh, good. Okay. I'm longer. Ah. I start the job. Go for it. Go, 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 go. Yes. Now it's in process. Hey, how can that? I enable it, right? Yeah. Alles klar. Oh no, oh, sorry. So now it's enabled. Here we go. Yay. Is it running? Oopala. Yeah, it's running again. Cool. Everything's fine. And now, when I now run a checkpoint to flush the transaction log, it should be, give it a few seconds. Yeah, here it is. Now the data has been grabbed. So you see, from my point of view, CDC is it's a wonderful feature for BI people, and it's a pretty cool feature if you only want to have dedicated data to get into the data warehouse. So here is the implementing of change data capture, and this is the what you can use to query it. Use SPCDC help change data capture, and this is the recommended access layer for querying CDC by Microsoft. Use this instead of the system tables. So here we go. That is the summary, and that was my business case. Long story short, in 2 minutes. So what they wanted to have is very simple. They wanted to audit the data, everything will change. The requirements were that the access needed to be permitted by Workers' Council. That was a hard story. So before anybody was able to access it, that had to be approved by the Workers' Council. Great thing. It took 2 days. Protection of personal data of employees was mandatory. So, and that was one of the key points. They wanted to have a dedicated, cheap storage. So what we did then was that we put the normal data on the drive F. F stands for fast. There was an SSD, yeah? So and what we did then, we created a different file group called CDC, and that was on the slow disk. And what we implemented was a barrier that we had a group which had only access to that schema, and that worked like a charm. That was a really wonderful thing. Here is the summary, and then we have proof. Tables with activated support net changes requires an additional non-clustered index, and so on and so on. I want to come to an end. Oh, this is one important point. Anybody is using database mirroring? You can use CDC with that. Yeah? So SQL agent need to be active on mirror instance. The procedure at job need to be executed on the mirror instance. Then it will create the jobs. So here we are. CDC was an enterprise feature. Since 2016, it can be used in standard edition. Use it. If you are not familiar with it, you have my email address. I travel for my life. It's wonderful. So, dziękuję, and I hope that I pronounce it correct. Do następnego razu.